All right. All right. Welcome, guys. This is part 2 of our data analytics for the CDP version 3. So I just jotted down some things that we will be going over today. And just to, as a review, the first one is one of the main things that I'm excited about for version 3 is the event type. It makes the whole analytics process just so much more easier. And yeah, so from last week, not last week, but from last time, we saw some duct type errors. Some numbers were assigned to some duct types which wasn't supposed to be there. But what we'll do is put in the GitHub issue, which we will talk about a little later. And then there was a little bit of corruption in Message Ids, so we'll look a little bit into it and also post it in a GitHub issue so that everybody in the community is aware of the issue and they can help solve the problem. And we did see some stranger ducks. I coined stranger ducks, but they're basically anomalies in the device IDs. And this might be a longer conversation, but we will be able to detect these stranger ducks and be able to figure out what to do with them. And lastly, we will plot the sensor data, and that will end this analytics playlist. So just a quick recap, what we did in the office in Owl HQ is deploy 4 ducks, 4 ducks in total, 1 popper duck and 3 sensor ducks. One of the ducks is an infrared sensor that's detecting movement. The other one is a BMP sensor, which detects temperature and pressure. And the other one sends out health quacks every few minutes to show how well the device is operating. And that gives us some insights of the progress of our protocol, the ClusterDuck protocol. So yeah, let's get to it. So we are going through the code. This is the code from last week. And just to recap, this is the event type, right? Now that we have the event types, it gets labeled depending on what sensor it's attached to. So in this case, these are the types of event types that we have. GPS, temperature and pressure, health, infrared, portal, meaning if someone submits a message in the portal, the captive portal that we have implemented in it, it gets tagged as a portal, and then the status, and also another BMP and sensor. All right, and then we graphed a little bit about the number of types of event types we have, and we have health skyrocketing. That being because all the ducks actually, for this deployment in our office, we did want to get the health status of all the ducks, so that's why we implemented a health point for all the ducks, and that's why the 4 ducks that we have here is sending out health data every so often. That's why health has the most number of messages. So we looked at the payload. This is a typical payload. This is how the protocol is set up. And as we progress, we'll add more stuff to the payload or take away stuff that's not needed. But yeah, this is a payload, and then some questions we have, and then the duct types. So the duct types of 2 and 1. So we looked at duct type. Mama ducks are typically supposed to be 2, but unfortunately we have these 4 anomalies here: 162, 6, 210, 98. I'm not sure what the duct type are. I don't think we have 210 ducks types yet. Maybe in the future. We have a lot of ideas spinning around of the types of ducks we can implement. And then the 1 here, the duct type 1 here, it's actually associated with the popper duck. So the popper duck also sends health quacks. So that duct type specifically would be 1. So yeah, for this, we can create a GitHub issue saying that sometimes there's a inconsistency with the duct type. For some reason, it's giving 162, 6, and 210. So I'm here at the GitHub repository in the ClusterDuck protocol, and I'll create the issue here. Bug report. Duct types. Actually, I want to make it duct type, yeah, capital T. Duct type. Huge. And numbers for duct type. Describe the bug. So duct type, some duct types of the messages are not normal. It comes out some values we received are 162.6.210.98. 162.98, 210, and 6. Not the exact order I said it, but that's exactly how I remember. Steps to reproduce. Deploy CDP v3. Actually, I should mention that. Not normal in version 3. Expected behavior. The duct types should be 2 for mama ducks and 1 for papa duck. So screenshots, yes, I can provide a screenshot here. Oop. The data is shown in OWL HQ from OWL HQ. All right. So got that down. So we'll look into it. And we can go to the next part. The duct type. Yeah, so interesting. It was only 1, 2, 3, 4 instances out of I forgot how many out of 145,000. So it doesn't seem significant, but it's good to jot it down that it can happen for later on. All right, hops. These are the number of hops associated. So if it was 1 hop, there was 11,000 times a hop once, which makes sense. All of the ducks in this office is within reach using LoRa. 0 hops, I would assume that's the papa duck sending the message. So the gateway is the papa duck. So if the papa duck is the one sending the message, then there's no hops at all. And 2, 4, 3, 15. The 15 one is interesting. But we can look at that. So hops are greater than 2. We did get one instance where it's 15 hops and the duct type is 210. So that could just be like a faulty. This ties with the duct type of 210. This could have just been a faulty message. And this is actually not part of the network we have. The device IDs we have are duck BMP1, papa duck, health duck, and IR duck. All right. So here we are looking at the device ID, the unique, and you can see that there's some corruption within the devices. We can get that fixed. And so we were as we were deploying CDP v3, we were also iterating on it. So there are some instances where we did change the name of the ducts in the beginning. So that's why some of these are it's a little different. And also we do test other ducts as well too. Like the Mama Duck 001, that was probably a test from a different ClusterDuck network. Okay. So based on these 4 ducts that's supposed to be in the network, these are the number of messages that were sent, and infrared, it makes sense. I think I mentioned it before. It just sends out a message when it detects a movement, and of course, there's a lot more movements throughout the day, so that's why it's just sending messages. Let's look at this a little bit more detailed, actually. Put these in quotes. I wonder if this works. In duck. If hold on let me figure out what I want to do first. No, I think it is. Okay. So df device. So I'm gonna try to isolate all these corrupted ones and see if there's some sort of pattern of when the corruption occurs. So if that apply, so lambda duck 1 if else 0. Okay. df corrupted device is equal to that. Okay. Now I'll copy this. df.lock is equal to 1. I wonder if my single device. Yeah, I'll get back to this one. Not sure why it's not, or maybe I don't know if this actually works. So yeah. So with the plan, I'll get back to this a little later, but I'll figure out how to detect these little corruption icons or, missed bytes, and then I'll figure out Okay, actually, let's break this down. So that works if lambda in row. Oh, that makes sense. So the reason why I wasn't detecting this is because if I scroll down, I filtered out all the other ones in DF, and now I went back and running it. So now DF doesn't have those. That makes sense why it wasn't detecting it. That was a... So yeah, I ran this at the 25th cell that I ran. So I already filtered out all those ones. So that makes sense why I'm not finding them. Actually, let's see if I could... I'm gonna rerun this. So rerun all above. Okay, yeah, there you go. These are interesting. There is still some corruption here. This one is actually, I'm not 100% sure where this... So this one is one of the testing that we were doing, but the IR duck here, the IR duck here, the IR duck here should be there. But this is something to jot down. So how many corruption there was? In this data we have length. Actually, I could just literally just count. 1, 2, 3, 4, 5. 5 divided by how many shapes we have? Percent corruption in device ID. Prints times 100. Yeah, so based on this, we have less than... Yeah, we... let me add a percent here. So yeah, the corruption, it's very insignificant. It's literally 0.003% of the time. There is some corruption in a device ID. So that's very significant. Right now, I can't see any patterns of when it gets corrupted. I was guessing that the more hops that it creates, that's the more chance it'll get corrupted. But if you can look at the hops, it's all normal. All right, so these are office ducks, BMP1, Papa Duck, and now I'm filtering out the device. I'm only getting the office ducks here. All right, I'm plotting the stuff. Yeah. Yep. So only one of them is close to a window, so they have access to the satellites, but the other two are like enclosed indoors, so it has trouble connecting to the satellite. So that's why we'll have some zeros here. But I think that's good for now. Okay, so now what's next? Corruption in the message IDs. So we did device IDs, now we'll do corruption in message IDs. So it'll be the same code here. Is message ID? Yeah, message, yep. df corrupted message is equal to 1 df.lock. Okay. All right. So yeah, once again, 3, 4, 5, 6, 7. 7 corrupted message IDs, which probably be another insignificant percentage, but it's good to jot down. Where are you? I'm just gonna copy this code. Corrupted in message ID. 7. 3, 4, 5, 6, 7. Yeah, about 0.005% corrupted. Actually, we should do something about this corruption. I mean, it is significant. I mean, insignificant, but if we do have a corrupted message, we do have two-way communications where we can say, hey, if the message is corrupted, push it back online, like, hey, we send that message. So be able to detect corrupted messages. If corrupted, request another message. So that'd be cool. So we're working on two-way communications, and that can be like a check. Something's corrupted in this message, I'll relay it back and say, hey, send it again. We'll see if that's possible. I'll talk with the team. All right, going back, anomalies and ducks, we did that. And then plotting sensor data. Okay, this will be the fun part. We have 3 sensors. We have 3 different types of data: health, status, BMP, and BMP IR. So here, BMP and BMP 180, they should be the same thing. So I'll change it to 180. So df event type is equal to BMP. I want all the rows. df.lock. Type is equal to BMP 180. Oh, run that. Oh, yeah, I think that's what it's complaining about. So this is filtering out based on rows, and this is asking for a column. I didn't need to do 2 columns. I need to do it separately. Okay, so now I'm gonna get the BMP data. Oops, BMP is equal to df.lock. All the rows dot copy BMP dot head. Oh, 180. I forgot I changed it to 180. All right, and now we can see that we got all the BMPs in one data frame. Do we need to reset the indices? Yeah, I don't see why we need to reset it, but I'll hold off for now until we have an issue. So now the next plan is get the temperature and pressure. So BMP payload. Why is it underlined? Oh, right, because it's not a cell. 180 BMP payload. That is str dot split. I'm splitting by okay, yeah, this is gonna be annoying. So some of the okay, so yeah, as we're reiterating on the version, there are some discrepancies here. There's some extra spaces here, so that's why it's not doing it. I mean, that's why we have 2 different types of data here. We have a list of 4 elements here, and we have a list of 2 elements here. So what to do? So I think what happened was, if it's a BMP here, that was like the old version, and which had like the extra spaces here, but the new BMP has the no spaces. So let's see, before we split it here, where did we split it? To list dot let's Google this. How to expand a series. Let's see. That's not what I wanted, but almost. Okay, put this here. Expand rows from list data available. I'm gonna try this. Yeah. Expanding. Oh. Okay, so that's not expanding. Is that all? Oh, that is all. Okay, so now, the question now is how do I split? The issue is one column has temp and some of the columns have temp and a temperature here. What to do? I can split by this. Yeah, okay, let's try that. A temp data frame is equal to this. Temp 0 should give me that. Dot str dot split by semicolon. Bam. Okay. Dot, and I'll apply pd.series. Okay. And of 1. Temperature is equal to, let me, I'm just gonna try to figure this out. Temperature, okay. Temp. One. Right, well, now we're looking, ooh, but that's not the pressure though. I'm gonna get a mix of mix of temperature sensors and temp of 1 is equal to, no, I don't want to do that. So let's do this. This is going to be a little bit more complicated. We might have to go back before. I think it'll be a lot more easier if, yeah, I think before we do this step, fix the BMP and then fix the BMP 180 and then combine it, and then, yeah, I think that'll be the easiest way. Someone cell, run all above. Bam, bam, bam. Percent corruption makes sense. I'm gonna add a file. BMP is equal to copy paste 180 copy BMP 180 is equal to df.lock BMP 180. I'm gonna highlight this for now just in case so I don't run it again. So BMP dot okay, because now whoa. Oh. Okay. We got this. So BMP payload now I can treat these a little bit differently. I will split by semicolon. What does that look like? Okay. Dot apply pd dot series. Okay. Actually, no, we do it by space. Oh man, we still run into the same issue. This is gonna take some time to figure out actually. But what we can do for time being with time, since we're a little time sensitive. Oh, 180 is also an issue too. All right, well, I guess I gotta figure this out now. We can do like a try except here. Try to maybe convert this to float. If it doesn't work, then return 0 or return -1, -99. Yeah, let's try doing that. Definition check for float. Pass in a row. Try. I'm not a fan of doing try and accepts, but yeah, float row. Else return -99. So the plan is, once we go through this, we'll just filter out all the -99. We'll know that the -99 is the string values. Oh, it's supposed to be except. We could do it if else, actually. Now I think about it. If let's just try this for now. Okay, t is equal to I'm just gonna df sample. I'll call it sample for now, just to make sure it works. And then sample 0.apply check for float. That didn't work because some of them are thing. Dot splits by str dot split by okay, actually, if we split by that, dot apply pd dot series. Oh no, we did that, right? Of ones. The issue comes here when yeah, this is going to take us some time. I think we will pause this for now, and I'll figure out how to do this, and then what I plan to do after we finish this data analytics series is actually write up a blog, and in the blog, once I finish, I'll actually I'll put the visualizations for temperature and pressure here. It's gonna take me some time, and I don't want to waste more time in a stream to solve this. To be continued. ... Run it. Okay, so now what we will do here is we will work on the, what's the other one? Infrared. Okay, IR is equal to df.lock, where df of event type is equal to PIR, I believe. Dot copy IR dot head. Okay, cool. So we have this information, and the good thing about it is each of them is very simple. Each of them are just, if it detects a motion, it'll send some information. So we have that info. All we have to do is, I think something fun would be being able to detect movement within how often we move in the office. Yeah. So what I'll do is plot it against time. pd dot to date time dot time. Does that work? dt dot time. Okay. That's actually a little scary right here. There's some movement around 12. Okay, so I am going to put IR. Oh wait, that makes sense. I'm supposed to put IR. That's a little bit more comforting. IR time is equal to that. What would be interesting? The hour, right? I'll be interested in to see how much foot traffic we get in an office within the hour. So I'm gonna do IR. Nope, not if IR. I want to time dot dt dot hour. Is it? Okay, so before we do this, let's just create that as a date time. Actually, I should have done that before we split, because I might have to do it for all the other ones as well. All the other event types. Okay, so all I have to do is, I don't need this anymore. I don't need that parentheses, and then that dt dot hour should be fine. Okay, IR hour is equal to that. So now IR dot group. I don't know what I want to do is group by hour. Payload dot counts. Would that work? Yeah. Plot kind is equal to h bar. Is that a thing? H bar in pandas plotting. I want to do it horizontal. I think that'll be a better picture. Pandas plot a horizontal bar. Bar H. So not H bar, bar H. Cool. PLT dot, that's not PLT dot figure fig size equals to, I usually go 12 by 8. I think 12 by 6 should be fine. PLT dot title motion detected hourly. All right, that's our, and then we need a that access label PLT that. So it might be weird because now that we have a horizontal plot, it might be Y label. Count of motion, number of motion counts. Oh, nope. All right, cool. So what does this tell us? It tells us that someone's, moving in the AM. There's a lot of movement at nighttime. This seems a little off. It seems like there's a lot more movement during not office hours. But I think that makes sense. I think what the issue is, when I imported a time zone, or when I downloaded the data, the time zone is not correct. I think it might be GMT. But yeah, I'll get back into that to see what the time zone for this data is. $12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14. So if we subtract 5 hours from GMT time, the data makes a little bit more sense. There's more activity in the afternoon, which makes sense, during the day we're programming, and after during lunch we all move around, eat everywhere, have meetings in conference table, and then we start working and collaborating more in the afternoon. So I'll get back to you on the time zone of this data. I have to double check on that. But yeah, so we can do that, and then what else we can do based on day? What day is the most productive? Pandas date time get day of the week. I think it's day of week or something. Yeah, day of week. Day of week. So is it like IR created? IR created. Nope, not if created at dt that day of week. Huh. Can I get the days or day name? Okay, cool. I don't know what that just what DT that. Oh. Okay. IR, not if IR day is equal to day name, and then I'll do the same thing here. Turn this into a code cell. Day, same concept. Motion detected daily. Yeah, seems reasonable. Weekends, there's some activity weekends. During the weekdays, Thursday and Monday are major days, more foot traffic, and that makes sense. We developed something called game day, where during our game days on Monday and Thursdays, meaning everybody's in the office and we're all collaborating. And then the other days we have opportunities to work at home remotely. So it makes sense. Monday and Thursday, there's a lot more foot traffic than the other days. This is awesome stuff. And what's left? Sensors and the health. So we have health. And this is valuable information. With the infrared sensor, you can detect foot traffic, and then you can detect any anomalies based on the foot traffic and see if, if Saturday's like a lot more foot traffic than the other days, then that probably is a little anomaly and something's probably happened. Maybe we had like a Saturday get together or something, which makes sense. But yeah, there's some interesting insights with these sensor integrations. All right, so now we will do health. Health is equal to df dot lock, where df event type is equal to health. And I want all the rows. Oh, what was that? Yeah, I need this looked fishy. I was like, what was that side square bracket doing? Oh, okay. I got thrown off a little bit. I'm like, it starts at 7,000, but yeah, it makes sense. So now the health cracks are different based on where the device ID is coming from. If it's from Papa Duck, it has a different health crack compared to a Mama Duck. So we can, with the time, I think we'll just look at the Mama Health Duck for now. With the time given is equal to health dot lock, where health of device ID is not equal to Papa Duck. Mama health dot head. Okay. Health Duck, blah blah blah. All right, cool. Now we have the payload, and now what we'll do is try to expand this. So
Yeah, I'm already seeing an error here. There's no space, or is this gonna be a problem? So, 31926. So this looks good. Yeah, so we have to fix in the firmware. So the protocol works. We just have to tweak the the firmware for the ducts. Just add a little space to make it a little bit more easier to analyze the data. Volts and temperature look a little weird, -3. But I'm gonna guess that's just because it's starting. Usually, like the first few temperature sensor readings are usually off, but once it gets acclimated to like the environment, it'll get back in track. So I'll stop it here for now, because I'm running into the same issue with being able. If I split by actually, this one might not be hard to do because we can split by charging. And huh. I feel like if I put split and split by C, it'll split the 24 and it'll put harging in the other side. So that might be a easier way to split the data. And can we do it this way? I'm just gonna check. That tail. What was, I'm just gonna print out the whole temp. Okay, yeah, what I can do is split by P. If I split by P, I'll get one side is temperature, the other side is pressure. Yeah, let me try doing that. Bam. So much easier to work with. Then I'll split by space, I believe. No, I have to split by semicolon and then strip the white space. And now I have all the numbers. Bam. So simple. Temp 0 that split. I think I have to str first. That splits by dot strip str dot strip. What's that. I feel like it's so much. There's a very more efficient way than keep on PD that series. One. That str that strip. Bam, got my temperature. And I'll do the same thing for pressure, and then that's how I'll get all the sensor readings. And after that, I'll plot it by time, and yeah. So overall, with our sensor integrations, it's working, and our protocol is a lot more efficient. Based on corruption, I think we're getting insignificant amounts of corruption, like 0.003 and 4% corruptions in device ID and message IDs. And then the duct types, we did get some issues, which we put in a GitHub issue. And what's left is the packet loss and the proper duct. And that I will work on this and create a blog for it. And I think I'll share the blog as well to finish off this stream, so that we won't have to do. So yeah, I'll write the blog to finish off the stream. I think that's how I'll end it. But yeah, so hopefully this was informative and interesting. Let us know, and if you want to join our community, feel free to check out the QR code. And if you have any questions, that's my name, and you can always message me in the Slack community, or that's my Twitter handle as well too, so feel free to message me there. And until then, thanks for joining.